Imagine an object so dense, so powerful that not even light can escape its grasp. An invisible giant lurking in the darkness of space. Today, we're venturing beyond the stars to uncover some of the most mind-blowing facts about black holes, from their mysterious beginnings to their strange behavior and the mind-bending science behind them. Let's dive deep into the wonders of black holes. To understand black holes, we first need to look at stars, especially massive ones. When a massive star, much larger than our sun, exhausts its fuel, it undergoes a spectacular collapse. The outer layers explode in a supernova, while the core collapses in on itself. If it's dense enough, the core forms a black hole. It's a process that ends a star's life but births one of the universe's most mysterious objects. This collapse creates something so dense and so powerful that nothing, not even light, can escape its gravitational pull. Black holes come in a range of sizes. There are stellar black holes, which are just a few times more massive than our sun. And then there are the monsters. Supermassive black holes, which are millions, sometimes billions of times more massive than the sun. The question of how supermassive black holes form is still a mystery. We find them at the center of galaxies, including our own Milky Way. It's strange to think that, at the heart of our galaxy, there's an invisible massive force keeping everything in check. The boundary around a black hole is known as the event horizon. It's called the point of no return, because anything crossing it is forever lost to the black hole's gravity. If a spaceship drifted too close, it would be torn apart, atom by atom, in a process called spaghettification. The idea of something being stretched into a thin string by gravitational forces sounds surreal. Yet, it's very real. And while we can't see past the event horizon, we can see objects and light swirling around it, creating stunning visuals we've only begun to capture. Did you know black holes can actually produce sounds? While sound, as we know, it can't travel in space, black holes release certain vibrations that scientists can detect with the right instruments. In fact, researchers discovered that some black holes emit sounds that, if amplified, would be around 57 octaves below middle C. Their vibrations so low they're impossible for humans to hear, but the universe is full of these inaudible, almost haunting echoes. Here's where things get really mind-bending. Black holes affect time itself. If you were to approach a black hole, you would notice something strange. Time would start to slow down. For someone watching from a safe distance, it would seem as though you were moving slower and slower. Near a black hole, time dilates dramatically. This effect, predicted by Einstein's theory of relativity, suggests that time itself can be warped. In theory, if you could hover just outside a black hole and then return, you might find that hundreds of years have passed for everyone else, while you've only experienced a few minutes. At the very center of a black hole lies a point of infinite density known as the Singularity. This is where the laws of physics as we know them break down. The Singularity has no volume, but it contains the mass of an entire star. It's a concept that baffles even the greatest minds in physics. We don't fully understand what happens inside a singularity, but some theories suggest it could be a gateway to another universe or even a different point in space-time. One of the biggest breakthroughs in black hole research came from Stephen Hawking, who proposed that black holes aren't actually eternal. They can slowly evaporate over time, losing mass through a process called Hawking radiation. In theory, black holes could eventually disappear, but this would take longer than the current age of the universe. So, while they might seem immortal, even these cosmic giants have an expiration date. Some physicists theorize that black holes could actually give birth to new universes. Imagine each black hole as a tunnel, a one-way passage to an entirely new universe. According to this theory, the singularity at the center could be a seed for a new Big Bang. It's a radical idea, but it hints at a universe far more interconnected than we once thought. Black holes don't just sit still. They can spin, and some rotate at nearly the speed of light. This rapid spin twists the fabric of space around them, creating what's known as frame dragging. As the black hole spins, it drags nearby objects and even light along with it. Imagine the power required to spin entire regions of space. This effect is one of the most dramatic consequences of black holes. When black holes merge, they create ripples in the fabric of space-time called gravitational waves. These waves were first detected in 2015, and it was one of the biggest discoveries of modern physics. The waves tell us not only that black holes are colliding, but also how massive they are, and sometimes even their spin. This wobbling and colliding of black holes gives us a glimpse into events that happened billions of years ago. The gravity near a black hole is so strong that it doesn't pull objects uniformly. It actually pulls more strongly on the parts that are closer to the black hole. This stretching force is known as a tidal force, and it can literally rip objects apart. Imagine being pulled so strongly that your head and feet are pulled in different directions, eventually stretching you into a thin line of particles. Spaghettification. It's a strange, brutal way for matter to end. Surprisingly, black holes can launch massive jets of energy across entire galaxies. These jets are made of plasma and can reach lengths of thousands of light years. Scientists think this happens due to the black hole's magnetic field, which funnels particles and energy out in a powerful beam. These jets are so energetic that they can affect entire galaxies, influencing star formation and the overall structure of galaxies. In theory, if there are black holes, there might also be white holes, objects that are the reverse of black holes, where matter can only escape and nothing can enter. Though we haven't observed any white holes, they're thought to exist as mathematical opposite. Some theorists suggest that white holes could be portals to other parts of the universe, or even other universes entirely. It's possible that some black holes were created not by collapsing stars, but right after the Big Bang. These are known as primordial black holes, and they would be incredibly small, but still dense enough to be black holes. Some scientists think these tiny black holes might even make up a portion of dark matter, the mysterious substance that forms most of the mass in the universe but can't be seen. Over billions of years, black holes at the centers of galaxies slowly grow as they consume nearby matter. Some scientists theorize that, over vast cosmic timescales, supermassive black holes could eventually engulf entire galaxies. This galactic cannibalism is still a distant possibility, but it's a reminder of the colossal influence black holes have on their surroundings. Some black holes exist in binary systems where they orbit another star. The black hole can pull material from its companion star, creating a whirlpool of matter called an accretion disk. This process can be so violent and energetic that it causes the black hole to emit powerful X-rays, which scientists on Earth can detect. This cosmic dance gives us a way to observe black holes indirectly. The largest known black holes are truly massive. One example is TON 618, a supermassive black hole with a mass of around 66 billion times that of the Sun. If it were placed in the center of our solar system, its event horizon, the point of no return, would stretch past the orbit of Pluto. It's a staggering reminder of just how immense black holes can become. The black hole firewall paradox is one of the biggest mysteries in theoretical physics. According to some theories, black holes should have a firewall at the event horizon, a point where anything crossing it would be incinerated. This contradicts other theories that suggest the event horizon would be smooth and uneventful. It's an unsolved puzzle in physics and one of the biggest debates about black holes today. A major mystery about black holes is the information paradox. What happens to the information about objects they consume? Quantum mechanics says information can't be destroyed, yet anything crossing a black hole's event horizon seems lost forever. Stephen Hawking suggested information might be stored on the event horizon or released as Hawking radiation. Solving this paradox could unite quantum mechanics with relativity, revealing new insights into gravity across the universe. If you tried to escape a black hole by flying directly away from it, you'd face an insurmountable challenge near its event horizon. This boundary is the point where the escape velocity, the speed needed to break free, equals the speed of light. Since nothing can travel faster than light, anything crossing this line is doomed to fall inward, no matter how fast it tries to escape. Even light, the fastest thing in the universe, is pulled back at this point. So if you found yourself too close to a black hole, you'd need a speed beyond any known laws of physics to outrun it. Black holes are some of the strangest, most fascinating objects in the cosmos. They challenge our understanding of reality, pushing the boundaries of science and imagination alike. Who knows what other mysteries these cosmic giants hold? Perhaps one day we'll uncover secrets even more extraordinary than what we can imagine now. Until then, black holes remain some of the universe's most captivating enigmas. Thank you for journeying with us today. If you're fascinated by space and the mysteries of the universe, leave a like and subscribe for more cosmic wonders.